Assalamualaikum and hi everyone. In this video, I'm going to summarize all reactions that you need to know in alkenes. It is divided into two types. The first one is electrophilic addition and the second one is oxidation. There are some reactions in alkene that is classified as electrophilic addition. Let's take 2-methylpropene as an example. So this is carbon number 1, number 2 and number 3. We have one methyl group attached at carbon number 2. The first reaction is hydrogenation, where it involves the reaction of alkene with hydrogen gas in the presence of catalyst. So the double bond is break apart and the hydrogen atoms is added to carbon number 1 and carbon number 2. The second reaction is halogenation in inert solvent, where the reactions involve the reaction of alkenes with halogen in the presence of inert solvent. The common inert solvent used is dichloromethane, which is CH2Cl2. So the double bond is break apart and bromine atoms are added to carbon double bond, carbon number 1 and carbon number 2. The third reaction is halogenation in water. The reagent is halogen, for example Br2 in water, H2O. So the double bond is break apart and bromine atom is added to carbon number 1 and hydroxyl group is added to carbon number 2. In halogenation in water, make sure the halogen is added to carbon-carbon double bond with more hydrogen atoms. Carbon-carbon double bond with more hydrogen atoms means carbon double bond that is directly bonded to hydrogen atoms. In this case, for 2-methylpropene, carbon number 1 is bonded to 2 hydrogen atoms and no hydrogen atoms directly attached to carbon number 2. The fourth reaction is reaction with HX or hydrogen halide, for example HBr or HCl. So the double bond will break apart. In this reaction, we must follow Markov-Nikov rule. So the hydrogen atom is added to carbon number 1 and the bromine atom is added to carbon number 2. Using Markov-Nikov rule, we must add hydrogen atom to the carbon-carbon double bond with more hydrogen atom, which is carbon number 1. Since carbon number 1 is directly bonded to 2 hydrogen atoms and carbon number 2 has no hydrogen atom bonded to it. But there is condition where we will not follow Markov-Nikov rule, or we call it as anti-Markov-Nikov, when there is a presence of peroxide or H2O2 in the reaction. So for this reaction, in this condition, since it is anti-Markov-Nikov, so bromine is added to carbon number 2 and hydrogen is added to carbon number 2 and bromine is added to carbon number 1. In this case, we add hydrogen atom to the carbon-carbon double bond with least hydrogen atoms. Remember, this rule is only applied when there is a presence of peroxide in the reaction. If no presence of peroxide, means we need to follow the Markov-Nikov rule, where the hydrogen atom is added to carbon-carbon double bond with more hydrogen atoms. In this case, carbon number 1, we add hydrogen atom, and carbon number 2, we add bromine atom. Reaction number 5 is hydration, where the reaction is between alkenes and H2O in the presence of acid catalyzed. In this acid catalyzed hydration, we still follow Markov-Nikov rule, where hydrogen atom is added to carbon number 1 and hydroxyl group is added to carbon number 2. So we actually add hydrogen atom to the carbon-carbon double bond with more hydrogen atoms. For the last 3 reactions, they are classified as oxidation reaction. Reaction number 6 is reaction with coal basic KMnO4. The reagent is KMnO4 in basic medium and coal. In this reaction, the product is diol, where 2 hydroxyl groups is added to carbon number 1 and carbon number 2. 2 hydroxyl groups is added to adjacent carbon, so the product is 1,2-diol. Reaction number 7 is ozonolysis. The reaction involves 2 steps. The first step is reaction with ozone, O3, and the second step is reaction with zinc and H2O+. In this reaction, the cleavage occurs between carbon-carbon double bond. Since the cleavage occurs here, so in this case, we will form 2 products. Since it is oxidation reaction, so we will have C double bond O at both products. So the products are carbonyl compounds. The products formed may be aldehyde or ketone. If the carbon-carbon double bond bonded to at least 1 hydrogen atom, it will form aldehyde. And if the carbon-carbon double bond does not bonded to any hydrogen atoms, it will form ketone. Reaction number 8 is reaction with hot acidic KMnO4. The reagent is KMnO4, the medium is acidic, and the condition is hot. Like ozonolysis reaction, reaction with hot acidic KMnO4 also will make the cleavage occur between carbon-carbon double bond. But in this case, 3 products will be formed here. The first one is ketone, the second one is carbon dioxide, and the third one is H2O. Carbon dioxide and water is only formed when the carbon-carbon double bond is bonded to 2 hydrogen atoms. But if we have other compound, for example, when we have methyl group here, the product for the right side will be carboxylic acid. Okay, the hydrogen atom that is bonded to carbon-carbon double bond will be oxidized to hydroxy group. So the product is carboxylic acid. In this case, we will only form 2 products. But since we are discussing the reactions of 2-methylpropane since the beginning, so the product of the reaction with hot acidic KMnO4 here will be 3 products, which are ketone, carbon dioxide, and water. So these are all 8 reactions of alkene you need to understand and you have to memorize. And here also we have two reactions for synthesis of alkenes. These two reactions are the preparations of alkenes from other compounds. The first reaction on how to synthesize alkene is dehydration of alcohol. We can synthesize alkene from alcohol using concentrated sulfuric acid as a reagent and heat. So the elimination reaction occur, one hydroxy group and one hydrogen atom from adjacent carbon is removed from carbon number 1 and carbon number 2. So the product is 2-methyl propene. And the second reaction is dehydrohalogenation of haloalkene, where we can synthesize alkene from haloalkene. So when elimination reaction occur, one bromine atom and one hydrogen atom from adjacent carbon is removed to form carbon-carbon double bond. So the product here is 2-methyl propene. So I think that's all for synthesis of alkenes and reaction of alkenes. I hope you can enjoy study organic chemistry and use mind map as a method to study organic chemistry. Okay, you must summarize all the reaction you have learned in each topic. Okay, that's all. Thank you for watching.